Hello friends, welcome to the video series on time and distance. This is the 8th video among the problem series. So let's begin with the questions. The 18th question. A train travels from Indore to Bhopal at a speed of 72 km per hour. But it had several stops in between, which took 60 minutes in total. If the average speed of the train for the entire journey was 50 km per hour, what is the distance between Indore and Bhopal? And the options are 166, 163, 168 and 169. So let's start the solution. We are required to find the total distance between Indore and Bhopal, and it is given that the average speed of the train was 50 km per hour while the actual speed was assumed to be constant at 72 km per hour. And we also know that the train stopped for 1 hour. So let's begin the solution. The approach to the problem in this case would be to consider two equations. That is, one of the average speed and the other one under the usual speed condition. So let us assume that if the train were to move non-stop, it would take a total of t hours. And let us also assume that d is the distance between both the places. We know that speed is equal to distance by time. So let us check the scenario in the usual case. We know that the speed is 72 km per hour. So substituting the value to this equation, we get 72 equal to d by t, or d is equal to 72t. Let us assume this to be equation 1. Now let us check out the other case of average speed. We know that average speed is equal to total distance divided by total time. So it is given that the average speed is 50 km per hour, the total distance remains the same as d, and the total time in this case would be 1 hour more than the usual time. So it would be equal to t plus 1. So our equation becomes 50 is equal to d divided by t plus 1. Now solving this equation further, we get d to be equal to 50 into t plus 1. Now let us equate the RHS of both the equations 1 and 2. We get 72t to be equal to 50t plus 50. The equation further reduces to 22t is equal to 50, and finally we get the value of t to be 2.33 hours. Now we come to the final part of the problem where we need to calculate the distance between both the places. This is really simple. We can substitute the value of t to either equation 1 or to equation 2 to find the final answer. Let us substitute this to equation 1. So the final distance would be equal to 72 into t, which in turn would give us 165.6 kilometers. If we go back to the options, we see that option A is 166, and that is the closest to 165.6 kilometers. So the correct answer is option A. I hope you've understood the problem. If you have any doubts, please comment below. Let us look at another problem. A man can swim 5 kilometers upstream in 1 hour and 4 kilometers downstream in 30 minutes. What is the speed of the river? The options are A 0.5 km per hour, B 1 km per hour, C 1.5 km per hour, and D 1.2 km per hour. So let's get started. This is one of the boats and streams problem. Let's see how is the approach to solve it. We're given that a man swims upstream 5 km in 1 hour while downstream 4 km in 30 minutes. We need to find the speed of the stream. So let us assume that the speed of the man in still water is m and the speed of the river or the stream is r. Now let us consider the cases individually. Let us consider the upstream case. We know that distance is equal to speed into time. It has been explained in the concept video that the relative speed may be calculated by subtracting the speed of the man in still water minus the speed of the river, because the direction of motion of both the objects would be opposite, and we know that distance is 5 kilometers. So our equation becomes 5 is equal to m minus r into 1, because he takes 1 hour to go upstream. Let us consider this to be equation 1. Now consider the downstream scenario. While going downstream, we know that the relative speed may be obtained by adding the values, and it is given that he goes 4 kilometers downstream, and that too in 30 minutes. 30 minutes may be converted to hours by dividing it by 60, which gives us half. So our equation becomes 4 is equal to m plus r into half. Rewriting the equation gives us 8 is equal to m plus r. Let us consider this to be equation 2. Now let us obtain the values of m and r from these two equations. For that, let us add equation 1 and 2. Adding 1 and 2, we get 2m to be equal to 13 and m is equal to 6.5 kilometers per hour. If you look at the video, it is given as 6.5 kilometers per second. It should have been 6.5 kilometers per hour. Now we need to calculate the value of r. To calculate the value of r, let us substitute this value in equation 2. Substituting it, we get r to be equal to 1.5 kilometers per hour. Now let us go back to the options and check which option matches with our answer. We see that option 6 is also equal to 1.5 kilometers per hour. Hence, the correct answer is option C. This video of problems on time and distance ends here. I hope you have understood both the problems. If you have any doubts, please comment below. If you found my video useful and interesting, please hit the like button and subscribe to my channel. Thank you.